Hello and welcome back to another PC build. To celebrate the release of Intel's 11th gen Rocket Lake CPUs and also the Z590 chipset, I'm going to be building a high-end gaming PC. And this is going to be another full step-by-step PC build guide where I'm going to show you how to put all the parts together to come up with a fully functioning PC by the end of the video. As well as this, I'll show you the important settings you're going to want to enable to get the best gaming performance from your new Rocket Lake CPU and Z590 motherboard combination. Then at the end of the video, I'll be running some benchmarks to give you an idea of the performance you can expect from the new Rocket Lake CPUs. So just before we get into the parts I've chosen for today's build, I want to talk about some of the benefits you can expect with the new Rocket Lake CPUs. So the new Rocket Lake CPUs offer a whole host of benefits over the previous generation, and Intel say you can expect up to a 19% IPC improvement compared to the previous generation. The integrated graphics in the processors have been significantly improved, and Intel say the performance has increased by 50%. The processors now support PCIe Gen 4, and we've got 20 CPU lanes, so that's 16 for a graphics card and 4 for a single Gen 4 M.2 SSD. We've got a new memory controller, and DDR4 up to 3200 MHz is now supported. The processors have a whole host of new overclocking features. We've also got new AI integration, and we've now also got support for the resizable bar. So for today's build, I'm going to be showing you the best that Rocket Lake has to offer, and I've got the flagship CPU, which is the i9-11900K. So this CPU is an 8-core, 16-thread CPU with a base clock of 3.5 GHz and a boost as high as 5.3 GHz. So I think the first thing we need to mention about the new processors is the current flagship model actually has less cores than the flagship model from the previous generation. So the 10900K actually had 10 cores and 20 threads, whereas the 11900K has 8 cores and 16 threads. So if we look at gaming performance, the drop in 2 cores shouldn't make that much of a difference, because in general 6 cores for gaming seems to be the sweet spot, and having 8 cores is going to be perfect for gaming and streaming. The one place where you would expect to see a drop in performance would be content creation, and in general, more cores is generally regarded as better. Actually, before coming on to make this video, I thought I would take a look at the DaVinci Resolve benchmarks for the new CPUs on Puget Systems webpage, and actually I was fairly surprised by the results. The new 11900K actually outperformed the 10900K in the overall score for DaVinci Resolve. As well as this, it actually outperformed the Ryzen 7 5800X. So even though the new flagship model only has 8 cores, the big improvement in the IPC seems to have brought benefits in content creation. And I'm really looking forward to testing the gaming performance later in the video. The other important thing that I want to mention is both the flagship i9-11900K and the i7-11700K both have 8 cores. So why would you pay the extra money for the i9-11900K? And I think the main advantages of the i9-11900K are higher clock speeds and access to 2 different types of boost technology that aren't available on the i7-11700K. While both CPUs have a range of boost technologies, it's only the i9 which has Intel's thermal velocity boost and also Intel's newer adaptive boost technology. And when you go ahead and pair the i9-11900K with one of the new Z590 motherboards and enable the adaptive boost technology in the BIOS, you can actually run all cores at 5.1 GHz simply by enabling one setting. This does rely on you having enough power and temperature headroom to allow you to do it. Now, Intel's adaptive boost technology is fairly new, and when the Z590 motherboards first came out, the BIOSes didn't support this. ASRock have sent me a beta version of the BIOS. I'm not sure if it features the adaptive boost technology, but if it does, we'll be enabling it and testing it out. So moving on to look at the new Z590 motherboards, and I think the first thing to say is the Rocket Lake CPUs are backward compatible with Z490 motherboards. So you already got a Z490 motherboard, you don't necessarily have to upgrade your motherboard. Importantly, the PCIe Gen 4 feature may or may not work with your motherboard. It's going to be motherboard dependent, and the only way to guarantee it to work would be to use a Z590 motherboard. Likewise, you can actually put one of the 10th gen processors into a Z590 motherboard, and while I was waiting for the Rocket Lake CPUs to arrive, I've actually used this motherboard with a 10850K CPU. So even though the new Rocket Lake CPUs will work with a Z490 motherboard, there is a few reasons why you may want to go with a Z590 motherboard, because the new chipset does offer a whole host of new features. I think probably one of the biggest reasons is if you want to use the new adaptive boost technology, it won't currently work with a Z490 motherboard. Other reasons are that the Z590 chipset has an integrated USB 3.2 Gen 2x2 controller, which will support speeds of up to 20 gigabits per second. Intel have also doubled the bandwidth between the chipset and the CPU and added support for Wi-Fi 6E and Thunderbolt 4. So as I'm keen to show you all the features of our flagship Rocket Lake i9 11900K, I'm going to be using a Z590 motherboard. The motherboard I'm using is the Z590 Phantom Gaming Velocita from ASRock, and this is not only a great looking motherboard, but it's a motherboard with a whole host of great features. It features a 14-phase power design, has a whole host of advanced features, so we shouldn't have any trouble getting the most from our flagship i9. I have made a separate unboxing and overview video for this motherboard, so you'll find a link to that in the description, and it covers all the advanced features this motherboard offers. And having already done a build with it, I can say I'm thoroughly impressed with it and can highly recommend it. So taking a look at the other parts I've chosen for today's build, for the case I've gone with Corsair's 4000D Airflow. For storage I've got a 2TB Gen 4 M.2 SSD from Sabrent. It's their Rocket 4 Plus drive. So this drive is Sabrent's revised version of their Gen 4 drive with a new controller which offers blistering fast speeds. We've got write speeds of up to 7,100 megabytes per second and read speeds of up to 6,600 megabytes per second. So this is going to be a great test for the new Gen 4 support of the Rocket Lake CPUs. For RAM, I've got 32 gigabytes of Kingston's HyperX Fury RGB at 3600 megahertz. So one of the things that's going to be really important in getting the most from our i9 11900K, and particularly getting the most using our adaptive boost technology, is that we have to keep the CPU cool and provide it with enough power so there's enough headroom to allow the CPU to boost. And I've really overdone it with the power supply, where I've got a 1200 watt power supply from BQuad. It's their Dark Power Pro 12. Again, we shouldn't have any problem keeping our CPU cool. I've got a 360mm AIO. It's the Deepcool Castle 360EX. As well, I'm going to be filling all the case fan locations in our 4000D Airflow. And for case fans, I'm using Lian Li's Unifans in white. For the graphics card, I've gone with the RTX 3080, which should give us some great gaming performance. The final item for today's build is purely aesthetic, and it's some white cable extensions from CableMod. So that's all the parts. Let's get on with the build. So we're going to make a start with the motherboard, and we're going to do as much work with the motherboard as we can while we've got it on the table, but it's much easier to work on a flat table than it is in the cramped confines of a case. So we're going to go ahead and install our CPU in this socket in the center of the motherboard, our M.2 SSD behind this heatsink. We're going to install our RAM here. As well, we're going to go ahead and install the back plate for our CPU cooler. And our motherboard also has a fan which we can actively cool the VRM with, so we're going to go ahead and install that option as well. So our CPU socket is hidden behind this protective cover. Just before I open the cover, I want to point one thing out. If you look at the corner down the bottom left hand side, you'll notice it has a triangle. And this triangle is to mark that corner of the socket, and we're going to line that up with a mark on the CPU. All we need to do is pull this little lever out, lift it backwards, and then we can lift the cover up. And you'll notice the reason the cover is on, there's lots of pins here in the socket that we don't want to damage. So when there's not a CPU in the socket, you've got this little plastic cover that protects the pins. This is our CPU, and what you'll notice is I'm holding it by the edges. And the reason for that is I don't want to get anything on these gold contacts on the back of the CPU. The other thing to point out, if you look at the bottom left-hand side of the CPU, you'll notice there's a little gold triangle. So we're going to line this up with the bottom left-hand side of the CPU socket. As well, you'll notice maybe about 3/4 of the way down the CPU on both sides, there's a little notch. And again, there's going to be similar notches on the socket. It's going to help us line our CPU up in the right orientation. All we need to do now is lower our CPU down onto the socket, and we're going to use the little notches on the side to help line things up. It's important we don't go pushing down on the CPU. It looks to be properly seated in the socket. And then all we want to do is lower this little cover down. Once we've got it down, we're going to close the lever. Don't be alarmed if the black plastic cover pops off during the installation. That's normal. So we're just going to lower the lever down, push it down under here, and then we can take this little plastic protective cover away. Importantly, don't throw this out, because once you take your CPU out of the socket, you're going to need to put this back on to protect the pins. This next bit is optional. The motherboard comes with a fan you can add onto the VRM to actively cool it. All you need to do is set it into place and then secure it with 2 screws. Then we can go ahead and plug the standard 4-pin fan connector into the VRM fan header, which is just here. Our motherboard has 3 M.2 SSD sockets behind the 3 heatsinks, but importantly it's only the top socket that will support Gen 4 speeds. And obviously if you don't use a Rocket Lake CPU, you're not going to be able to use this top socket. So to access the socket we need to remove the heatsink. It's held on by 2 screws. To install our M.2 SSD, all we need to do is insert it at a slight angle into the socket. Then whenever we re-secure the heatsink, the screw that holds the heatsink on is also going to secure the drive. Just before we put the heatsink back on, it is important we remove the plastic protection. We can then go ahead and line the heatsink back up again. To install our RAM, we just need to open the clips on the top of the slots. Then all we need to do is line the RAM up in the slot. Once we're happy everything's lined up, we just need to apply some firm pressure to the top of the RAM. It's going to clip into place and the clip will close, securing it. Just the same thing with the other 3 sticks of RAM. The final thing I want to do before we go ahead and get our motherboard into the case is to install the backplate for our CPU cooler. Now the reason I like to do it now is quite often when you've installed your motherboard into the case, depending on the case, you may or may not have access to where the backplate goes and the back of the motherboard. So it's always a good idea to do it at this stage so you're not going to have to take the motherboard out when you discover it won't fit. So all we need to do is go ahead and line the backplate up with the back of the motherboard. We can then go ahead and turn things over. And then to hold things in place till we're ready for it, I'm just going to put the thumb screws that will actually secure our CPU cooler in place. Okay, we're now ready to get the motherboard into the case. To remove the tempered glass side panel, we just need to simply loosen the captive thumb screws at the back. Then all we need to do is pull the panel outwards from the back, and then we can pull it away. Same process with the other side panel. We just need to loosen the thumb screws, pull the panel out, and then lift it away. We can simply remove the front panel by pulling it away at the front. Beneath that we've got a dust filter. If we pull this down we can lift it away. We've also got a magnetic dust filter at the top which can simply be lifted away. We're not planning on using the stock fans that came with the case, so we can go ahead and remove them. There's 4 screws holding it in place. Same thing with the fan at the back. Again we just need to remove the 4 screws holding it in place. At the rear of the case you can see there's plenty of spaces for mounting drives. We've got 2 dedicated 2.5-inch drive mounts, and we've also got a hard drive cage which will accommodate 2 drives down the bottom. We're not going to use the hard drive cage, so we can go ahead and remove the drive trays. And this is in general where you will find your case accessories. So we're going to find all the screws we need to secure our motherboard and our power supply, and quite often you'll find cable ties and some instructions in here as well. So as we're not actually going to be installing any hard drives, I'm going to go ahead and remove the hard drive cage, which is going to make more space down the bottom of the case for our power supply cables. It's just held on with 2 thumb screws at the side. With our hard drive cage loosened, all we need to do is pull it backwards and then it can be removed from the case. And you can see we've now got significantly more space down the bottom for cables. We're now ready to go ahead and get our motherboard into the case. What you'll notice is we've got 9 standoffs at the back to secure our motherboard. The middle standoff is, however, different. All the other standoffs have a hole. This one is solid and elongated, and it's designed to go through the center hole of your motherboard, hold your motherboard in place, allowing you to get the other standoffs into place, so you don't put a screw into this middle standoff. The other important thing to mention, we do have a code at the back of the case. We've got an ATX motherboard, so the standoffs are all in the right place. If you've got a different size of motherboard, you need to refer to the code and you may need to move some of the standoffs. And we do have additional standoffs in the accessory box. 2 other things to mention: if your motherboard doesn't have an integrated I/O shield, you should go ahead and install it first before installing your motherboard. And the second thing is, I install my motherboard with the case upright to give you guys a good look at things. You will, however, find it much easier if you lay the case down on its back to install the motherboard. Okay, so I'm going to go ahead and insert the motherboard into the case, lining things up with the back, and then I'm going to try and get that middle standoff through the hole in the motherboard. And you see it's slipped in, and actually, without doing anything else, it's holding the motherboard in place. So we can go ahead and get the other screws into place. One of the things I'm just noticing is the optional fan we've installed to cool our VRM is actually blocking one of the screws. I could go ahead and remove the fan and then install the screw and put the fan back on, but actually our motherboard's going to be held perfectly well just as it is. And like I say, I generally do these just for YouTube. The builds tend to last a week or so before I tear them down, so it's going to be absolutely fine. If this was a long-term build, I would take the fan down, put the screw in, and then put the fan back on. The next thing for us to do is to go ahead and get our case cables plugged in, and these are the case cables coming from the front I/O. So looking at what we've got a HD audio cable which lets our headphone and microphone jack on the front of the case work. We've got 2 cables for USB. This one here is for our Type A port, and this one here is for our Type C port. And we've also got our front panel connectors. They allow our power switch, reset switch, and power LED functions in the front of the case to work. The reason I like to plug these in at this stage is we've got lots of good access to the motherboard. If we leave things to later on, when we've added more fans or I/O in, it gets much harder to plug the cables in. The other thing to note here is we can see our backplate for our CPU cooler, and actually we wouldn't have any problem installing this at a later stage. Other cases, it will partially block where the backplate goes, and actually once you've got the motherboard in, you're not able to install it. So our HD audio cable is going to go into this header down the bottom left hand side of the motherboard. So we just need to go ahead and bring it through the cutout closest to the header. If we did close at the header, you'll notice in the top row there's a pin missing, and also the cable itself has a hole missing, so it's important we line things up the right way. Once we've got things lined up, we can go ahead and push the cable into place and then go ahead and pull the excess cable through to the back. Our front panel connectors are going to go into this header down the bottom right hand side of the motherboard, and it's really important you prior to the diagram in the motherboard manual so that you're plugging these cables into the right pins, because they're all going to need to go onto the one header. What I would recommend doing is starting off in the bottom row and working your way up. If you start in the top row, you're not going to be able to see the bottom row to plug the cables in. Okay, so starting off with the bottom row, we're going to plug our reset switch into the pins 3rd and 4th from the left hand side. It doesn't matter which way the reset switch goes in, so I'm just going to plug it in with the text facing down the way. Moving up to the top row, working again from left to right, the first pin is for power LED positive, and next to that we've got power LED negative. I'm just going to again plug that in with the text facing down the way. Pins 3 and 4 from the left hand side in the top row are for our power switch. Again, it doesn't matter which way this one goes. Again, I'm just going to plug it in with the text facing down. And then when we've got all the cables plugged in, we can go ahead and pull the excess cable through to the back. Our front panel Type C header is just here, so I'm going to go ahead and bring the cable through the cutout, line it up, and then push into place. Next we've got our USB 3.0 cable, and this motherboard has 2 headers we can plug into. We've got a right angle connector here and a standard connector here. I think it's going to look much better in the right angle connector, so I'm going to use it. Looking at the cable, we've got a little notch on one side and our header also has a notch on it, so it's important we line things up the right way. Okay, so once we're happy things are lined up, I'm just going to apply some firm pressure and the cable is going to clip into place. We're now ready to go ahead and get our power supply into the case. I've gone ahead and plugged all the cables and cable extensions in. So we've got 3 PCIe cables for our graphics card. We've got 2 8-pin EPS cables for additional power to the CPU. We've got a 24-pin cable for our motherboard. And we've got a SATA cable, and we're going to need to power the controller for our fans. So importantly, our power supply does have an intake fan, and we're going to want to install it with the intake fan facing down the way. So all we're going to need to do is slide this into the back of the case. And then we can go ahead and secure things into place with 4 screws at the back. Next we can go ahead and plug in the cables, bring in additional power to the CPU, and they go into these 2 headers at the top of the motherboard. Go ahead and line things up and push into place. Now the cables have cable combs which are going to help organise the cables. Then we can go ahead and bring our 24-pin connector through here, line things up with the motherboard, and then push into place. And again, this cable has some cable combs which are going to help organise the cables. We're now ready to go ahead and get our AIO installed. The Deepcool Castle 360X comes with 3 standard black fans without any RGB on them, so I don't think that's going to look particularly great. The Lian Li Unifans are actually quite good radiator fans as well as case fans, so I'm going to use them both on the radiators and as case fans. So the first thing for us to do is to join the 3 fans together. To do that, all we need to do is line them up. Once they're lined up, we just simply need to push them, and that's the 2 fans joined together. Same thing with our third fan, we just need to line it up and then slide it into place. Then all we need to do is add 1 connector into the 3 fans that we have plugged together, slide it into place, and then at the end of this we've got 1 standard 4-pin fan connector and a Lian Li RGB connector. So we've just got 1 set of cables, and that's going to power and light all 3 of the fans. The next thing for us to decide is which way we're going to put the fans on the radiator. The only place a 360mm AIO is going to fit in this case is at the front, so it makes sense to have it as an intake. If we have an AIO as an intake, we're going to get significantly better CPU temperatures than having it as an exhaust. So that just makes sense because we're going to be bringing cool air from outside the case through the radiator, which is going to give better cooling potential than where you would have an exhaust pushing hot air from inside the case through the radiator. That's going to have less cooling potential. And given that we're looking to get the most from our CPU, to do that we want it running as cool as possible. So we still have 2 options. We can either have the fans in front of the radiator pushing cool air through the radiator from outside, or we can have them behind the radiator pulling cool air in. There is some differences. Some of them are aesthetic, some of them are related to noise as well. I've generally found having the fans in the case pulling is much quieter than having it at the front pushing. And aesthetically it depends on the case, whether you want the lights showing on the outside or whether you want the radiator showing on the inside. I think it's actually going to look much better with the fans on the inside rather than having the black of the radiator on the inside. So I'm going to have the fans in the inside of the case pulling air in from the front. So that means we're going to need to insert them this way round. Then all we need to do is secure them into place using the long screws that came with our AIO. Now just before we go ahead and get this into the case, I have actually turned the fans round so the cables coming from the fans are up the same side as the tubes. When I sized this up in the case, with the cables coming out the bottom, they just weren't going to reach up to the top of the motherboard, and that's where our CPU fan header is going to have to plug in. Next we can go ahead and insert the AIO into the case. Then we can go ahead and secure the AIO into place using the short radiator screws. Then we can go ahead and replace the dust filter. and also the front panel. Next thing to do is to apply a pea-sized amount of thermal paste to the centre of the CPU. Then we can go ahead and line our AIO up with the backplate. Importantly, if you are using this for the first time, there's going to be some plastic protection on the cold plate that you're going to need to remove. I've used this before, so I don't need to do that. So we'll go ahead and line up with the backplate. And once things are lined up, I'm just going to apply a little bit of pressure to the top. I'm then going to take the thumb screws that we had inserted earlier on and start adding these on to the cooler. Okay, that's the thumb screws on loosely. All I'm going to do now is tighten up each of the corners. Coming from our AIO, we have got two wires. We've got a 3-pin fan connector, which is going to need to go into our pump fan header, which is at the top. The one closest to the middle is for the CPU fan header, and the one next to it is our pump fan header. The other cable is a standard 3-pin 5V addressable ARGB connector, which is going to need to go into this header on the top of the motherboard. So we'll go ahead and get both those plugged in. Okay, that's both those cables plugged in. We can then go ahead and pull the excess cable through to the back. Next I'm going to go ahead and plug in the fans and the radiator into the CPU fan header just at the top of the motherboard. So for the top of the case, I've got two Lian Li Unifans which have linked up exactly the same way as what we did on the radiator. And then we can go ahead and put the dust filter back on at the top. Okay, so we've got a single rear fan. So first thing, we'll go ahead and pass the cables through to the back and then go ahead and get things secured into place. We're now ready to go ahead and connect up our fans. They're going to need a controller, and the controller is going to need 3 cables plugged into the motherboard. So I'm going to go ahead and plug the cables in now. The first is a USB 2.0 cable, and it's going to go into this header here. Looking carefully at the header, you will notice there's a pin missing in the bottom right hand corner. So we're going to need to plug the cable in the right way because the cable has a hole missing on it. So we'll go ahead and plug that in. And then I'm just going to go ahead and feed the excess cable through to the back. Our controller is going to need to plug into one of our system fan headers, so I'm just going to go ahead and plug the cable into here. The final connector to plug in is another 3-pin 5V addressable ARGB connector, and we've got another header down at the bottom of the motherboard. Okay, so this is our Lian Li controller for our Unifans. So it's got 4 different channels on it, 1, 2, 3 and 4. And each channel has 2 connectors. One is for a 4-pin PWM fan connector, and one is for a Lian Li ARGB connector. On the other side of the controller, we've got 3 connectors. One is for SATA power, one is for USB, and the other is where the dual cable that we plugged in, one going to the 4-pin PWM fan connector, and the other end going into a 5V 3-pin addressable ARGB connector. Okay, so I'm going to make a start by plugging in the SATA connector for power. It's going to go into this one all the way over here. Then all I'm going to need to do is to plug in the other end of this into one of the SATA cables coming from our power supply. This is the dual cable I was talking about. One end goes into the 4-pin fan header in our motherboard, and the other goes into an addressable ARGB header. So I'm going to go ahead and plug it in. Then the final connector in the middle is for USB. So I'll go ahead and plug it in. Then, as we've mentioned, coming from each of our groups of fans, we've got a 4-pin fan connector and an ARGB connector. So I'm going to plug the rear fan in first of all. So plugging in the PWM fan connector and then also the RGB connector. Then our fans at the top of the case. Now our fans in the radiator, we've only got one connector left. I've already plugged the 4-pin fan connector into our CPU fan header, so we've only got the RGB connector, so I'm going to plug it into channel 3. So this is going to mean that the controller is going to control the RGB for all the Unifans. Our motherboard's chassis fan header is going to control the fans that are plugged into this controller, whereas the CPU fan header is going to control the fans on the radiator. We're now ready to install our graphics card, and to do that we're going to need to remove the second and third slot covers from the top. To prepare the motherboard to receive the graphics card, all we need to do is open the slot. Next we can go ahead and line our graphics card up with the slot. Once we're happy everything is lined up, we can just apply some firm pressure. The graphics card is going to clip into place and the slot is going to close. We can then go ahead and secure the graphics card with the thumb screws we removed earlier on. We can then go ahead and plug in the power supply cables. Again, we've got some cable combs on the cables to help tidy them up. Our final job is to tidy the mess of cables up so we can get the side panel back on. Importantly, we do have lots of cable tie points, and we've got cable ties in the accessory box. We've also got some Velcro scraps, and we've got some space down the bottom for the power supply cables. So that's the PC up and running. I've gone ahead and installed Windows 10, all the drivers, installed the RGB software and set it up. The reason I didn't record those steps is because in a recent build guide in the O11 Dynamic Mini, I used exactly the same hardware. So these steps are exactly the same as what I did in that video. So you'll find a link to that video in the description if you need any help with these steps. But what I really want to focus on now is optimizing our PC for our new Rocket Lake CPU. So I want to head over to the BIOS and show you the settings that you should enable. So to do that, we're going to go ahead and restart our computer. And whenever the screen goes black, we're going to start pressing the delete key to enter the BIOS. So I'm just going to wait till things go black here. So the screen's black, I'm going to start pressing the delete key. And then just as the ASRock logo appears is the time we need to hit the delete key, and that should take us into the BIOS. Okay, that's us into the BIOS. Okay, the first thing I'm going to do is go ahead and click on the advanced mode. I'm then going to go ahead and click on OC Tweaker, and we're going to make a start with our RAM. So I'm going to click on RAM configuration. So at the moment our RAM is running at 2400 megahertz as we can see here, but we've actually got two XMP profiles. Our RAM can run at 3600 megahertz, so that's the one I'm going to enable. So I'm going to click on Load XMP Settings, and I'm going to click on Profile 1. Okay, that's the first job done. So we go back to the OC Tweaker main screen, and we're going to click on CPU Configuration. And we'll work our way down. Okay, so we can see all the different types of boost technology that are available. As we've mentioned, the two types of boost technology that we're going to get with our i9-11900K that you're not going to get with the other CPUs is Intel's thermal velocity boost and also the adaptive boost technology. Now, as I've mentioned, the adaptive boost technology is a fairly new type of technology, and on the original release of the CPUs, this wasn't mentioned. It only came out later on. And if you actually have the public version of the BIOS for the motherboard, this option isn't going to come up. ASRock have sent me a beta version of the BIOS, so I do have access to this feature. What we can see by default, Intel's thermal velocity boost is enabled, but the Intel adaptive boost technology isn't. So I'm going to go ahead and enable it. So I click on disabled and click enabled. So later on when we do the benchmarks, I'm going to test both with and without this turned on to see the difference it offers. Okay, the last thing I want to do in the BIOS is to enable the resizable bar. So we click on advanced, we're going to click on chipset configuration. What we're going to need to do is turn on above 4G decoding. It's currently disabled. If we turn it to enabled, another option is going to pop up, which is clever access memory. So this is what ASRock call the resizable bar. So we click on disabled, click enabled. It's going to turn on the resizable bar support. So I'm going to go ahead and click on exit, save changes and exit. It's going to give us a summary of all the things that we have adjusted, and I'm going to click yes to confirm. And our computer will now boot back into Windows. Okay, that's us back into Windows. The first thing I want to do is check that all those settings have been enabled. So if we right click on the Windows icon, click on Task Manager, click on Performance, click on Memory, we can now see our memory is running at 3600 megahertz, so that is fine. The next thing I want to do is check support for resizable bar has been turned on. So we click on the NVIDIA settings, and then we're going to click on System Information, and we can see resizable bar has got a yes beside it, so it has been turned on. Okay, so to check that Intel's adaptive boost technology is on, I'm currently running Cinebench R23. We're doing a multi-core test, and what we can see that all the clocks are running at 5088, so that does seem to be enabled. What I'm going to do, I'm just going to let this test run for the 10 minutes to keep an eye on our temperatures. We can see the CPU temperature there is currently at 82 degrees. Okay, that's us into our second run of Cinebench. It's been running for over 10 minutes now, and we can see our maximum CPU temperature is 84 degrees, which is very acceptable. So let's take a look at the results. So looking at the results, we can see with Intel's adaptive boost technology turned on, we've got a single core score of 1651 with a multi-core score of 16374. So I've gone ahead and ran the same test again with Intel's adaptive boost technology turned off. Our single core score has dropped down by 1.3%, while our multi-core score has dropped by 6.4%. So it does definitely seem that the adaptive boost technology is adding significant benefit. So the next benchmark was TimeSpy, where we got a CPU score of 13,291 with the adaptive boost technology turned on. Turning off Intel's adaptive boost technology, and our CPU score dropped to 12,763, which is a reduction of 4.2%. So again, a significant benefit to the adaptive boost technology here as well. Next up was Crystal DiskMark to test the speed of our Rocket 4 Plus M.2 SSD, and we can see our Z590 motherboard is giving us great speeds. We've got a read speed of 6,944 megabytes per second, while we've got a write speed of 6,604 megabytes per second. Moving on to the gaming benchmarks, all games were tested at a resolution of 3440 by 1440, and if DLSS was available, it was used in performance mode. Starting off with Shadow of the Tomb Raider, using the game's built-in benchmarks with the graphics settings turned up to the highest, we had an average frame rate of 137 frames per second. Next up was Assassin's Creed Valhalla, again using the game's built-in benchmark with the graphics settings turned to ultra high. Here we had an average frames per second of 69. Next up was Watch Dogs Legion. Using ultra graphics settings, we had an average frames per second of 76. In Valorant, using high settings, we had an average frame rate of 358. Last up was Fortnite. Using epic settings, we had an average frame rate of 239 frames per second. So what about Intel's adaptive boost technology? How much of a difference did it make with gaming? So I went ahead and turned it off and ran the same benchmarks. So looking at the results in terms of frame rate, we didn't see any benefit to having Intel's Adaptive Boost technology turned on in both Assassin's Creed Valhalla and Watch Dogs Legion. In Shadow of the Tomb Raider, we got a 0.7% improvement in frame rates, while in Valorant we got a 5.3% improvement and a much better improvement in Fortnite, with frame rates increasing by 32%. So looking at the Adaptive Boost technology, it really depends what you're doing with your PC as to whether you're going to get a benefit from it or not. But in certainly some of the tests, you did get a significant benefit. So it's a really nice feature to have. So what about the cost of running Adaptive Boost technology? Obviously, if you're running all your cores at a faster speed, they're going to run hotter. So looking at the results when we were gaming, all the temperatures were actually still pretty reasonable, but having Adaptive Boost technology turned on, the CPU ran on average 7 degrees hotter. So summing up the benchmarks, gaming at 1440p on an ultra-wide monitor with the graphics settings maxed out, the performance was excellent and we got some great frame rates. And importantly, temperatures were fairly acceptable as well. So this is an absolute beast of a gaming PC and I've had great fun putting it together. So big thanks to both ASRock and Intel for making this build possible. So hopefully you found the video useful. If you did, please give it a thumbs up. And if you're not currently subscribed to the channel, please click the subscribe button as well. Both of those things really help me out and I really appreciate them. Thanks for watching.